Okay, everybody, it is review day 2. So today's kind of more of our rational functions, our rational expressions. So let me start with number 1. We're going to graph 12 divided by x minus 4 plus 1. So the first thing, let me do my xy axis. I know that, first of all, because of the negative 4, f of x equals 12 over x minus 4 plus 1, that x cannot equal 4. So I'm going to put an asymptote at 4 for sure. And then I'm going to have a horizontal asymptote at 1, okay? So I've got my asymptotes y equals 1 and x equals negative 4. Those are my asymptotes. Now I want multiples of 12 to graph this, and so I'll start with, just 4 times 3 from the translated axes. 3 times 4, 4 times 3, 6 times 2, 2 times 6, and of course, the rest is not going to fit the 1 and the 12 and so forth and so on. But it looks like that. Same thing from the translated axes here. I'm just going to go 3 and 4, 4 and 3, 2 and 6, and 6 and 2, and of course the 12s are in there somewhere, okay, 1 and 12. There it is. There's my graph. Okay, domain range. Domain is going to be x equals all real numbers except x cannot equal 4, right? Because then you divide by 0. And the range is y is equal to all real numbers except for y cannot equal 1. Okay, that's question 1. Let's look at 2. Okay, simplify the following rational expressions. Number 2, I'm just going to factor. There's a 1 there. So we'll factor x minus 4, x plus 3, and we'll factor x squared minus 9 into an x plus 3, x minus 3. We'll get the x minus 3's. Bye, guys. X minus 3 or x plus 3 is to cancel, and then my answer is going to be x minus 4 over x minus 3. Okay, good. 3, I need a common denominator, so I'm going to take out an x plus 2, and then what I need to do is make sure they have a common denominator. Well, if I look at this, both fractions have an x plus 2. The first fraction has an x, so I'm going to multiply the top. Second equation by x over x, the rule of 1. So now my common denominator is going to be a x times an x plus 2. My numerator is going to be a 2x plus 1 plus a 3x. I can combine the terms on the numerator, and I can have a 5x plus 1 over an x times an x plus 2. If I could factor and cancel, I would, but I can't, so I am done. Okay, so there's my answers. There's my answers, okay? Number 4, if I multiply, first thing I'm going to do is factor as much as I can. I'll rewrite this x squared, x minus 2. Those will not factor, but the second fraction will factor x plus 5, x minus 2, and then I'll common factor out an x. I'll have an x times an x plus 2. Looks to me like I can cancel x plus 2. I'm sorry, x minus 2 with x minus 2. Really? That's it? Wow. Shoot, I should have made a better problem. Oh, I can do an x for an x. Wow. Man, I wish I'd made a better problem because not much cancels, but I do have a x times an x plus 5 over an x plus 2. That's all I can do. All right. 5. I'm going to invert and multiply, right? Flip the second fraction. So I'll rewrite it. 5x to the 4th y over 4x cubed times 2y to the 4 over a 15xy. And anything on top will cancel with anything on the bottom. We'll start with the whole numbers. 5 and 15 would reduce to 1/3. 2 and 4 reduce to 1/2. Let's see, 3 of these x's can cancel 3 of these x's, which is just leave an x over. But there's still more x's. I have an x here. They can cancel with that x. Okay, now with the y's, I've got one y here. Cancel one of these. Y cancels. I'll leave it with 3. Y cubed left over, and I think that's all that can be done. So multiply straight across, and I have a 1y cubed over 6. Okay, all right. Turn the page. I gotta multiply. So to solve for x, if I have a fraction equal to a fraction, I cross multiply. So this comes up here, this times this equals this times this. So I cross multiply. I bring up, cross multiply the x plus 2. I bring up the x plus 1. Called cross multiply. Now I'm just going to simplify by foiling. I will get an x squared plus a 2x plus a 4x plus 8. And that will, of course, simplify to an x squared plus a 6x plus 8. I'll do the same thing. I'll foil here. X squared minus 3x plus 1x minus 3. And, of course, that will simplify to x squared minus 2x minus 3. Okay? If I subtract x squared from both sides, x squareds are gone. That makes it easy. So then I just really have a 6x plus 8 equals a negative 2x plus minus 3. To solve, I'll go plus 2x, 8x plus 8 equals negative 3. I'll go minus 8, 8x equals negative 11. Divide and I'll get negative 11/8. Okay, there's my answer. And I'm okay because up here x cannot equal negative 1 and x cannot equal negative 2 because those values make me divide by 0. Okay, so I'll keep this answer. Negative 11/8 seems to be just fine with me. Okay. All right, 7. Well, to get 7, I need a common denominator. Well, let's see if I can do this. 2 over 1. So my common denominator on these two is going to be 3x. So I'll multiply this by x over x. Multiply this one by 3 over 3 so that my common denominator is 3x. And if I add these two, I'll have an x squared minus 12 equals 2. 2 over 1. Now, at that point, I can cross multiply, which makes it pretty easy. So cross multiply. Let's see, I'll get an x squared minus 12 equals 2 times 3x, which of course is 6x. I just cross multiply. I don't really need the 1. Then I'll have an x squared minus 12 equals 6x. Looks to me like I'm probably going to have to factor, so bring the 6 over. X squared minus 6x minus 12. Ooh, that might not factor. So if it won't factor, I probably need to use the quadratic formula to get that answer. Let's see. 6 and 2, 3. Yeah, it won't factor. So negative b. So it will not factor. So I got to use a negative b plus minus square root b squared minus 4ac all over 2a. All right, so negative b plus or minus square root of b squared minus 4 times a times c all over 2a. 6 plus or minus square root of 36 plus 48 over 2. 6 plus or minus square root of, let's see, what is that, 70, 80, is that 84? I think so, 84 over 2. And then, let's see, 84 probably reduces as a square root. Let's see, 4 goes into it 21 times, so 6 plus or minus square root of 4, square root of 21 over 2. So my two answers would be 6 plus or minus 2 square root of 21 over 2. Or finally, 3 plus or minus the square root of 21. Ooh, that's hard. Hopefully the one on the test is easier than that. Okay, 8. Find the inverse and restrict the domain to allow to be able to graph both the inverse and the function. So let's do number 8 on graph paper. So first to find the inverse, I could probably find the inverse. Let's just do it on graph paper. C graph. All right, number 8. F of x equals x squared minus 9, or y equals x squared minus 9. I do an inverse, I switch the variables. X equals y squared minus 9. Add 9, x plus 9 equals y squared. Square root of both sides to get rid of the square, but I'm going to have a plus or minus. So I really have a plus or minus, excuse me, plus or minus square root of x plus 9 equals y. Now you can't have plus or minus. So then what we're going to do is we have to change the domain. So let's go back and look at the original graph. Okay, so if I look at the original graph, if I were to graph let me get a different color because I like colors. My original function, if I graph my original function, I will start with -9. 1, 2, 3, 4, 5, 6, 7, 8, 9, and I'm going to graph by going 1, 1, 2, 1, 2, 3, 4, and then 9. So then the original graph actually looks like this, and I'm going to use pencil and like this because I'm going to erase this back half. Okay, there you go. Now, knowing that, when I do the inverse points are all like this. I'm going to have a 0, -9. I'm going to have a 1, -8. I'm going to have a 2, -5. I'm going to have a 0, 3. If I want the inverse of those points, I'd have a -9, 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'd have a -8, 1. I'd have a -5, 2, and I'd have a 3, 0. So my graph would look like that. Okay, if all I did is I just reversed all these points. Because it's the inverse, right? So you switch them, and then I graph those. Okay, graph those points right up here. Now, we can't have the bottom half. So what we do is we change our domain. So we have a domain change. Domain change. We're going to go, okay, let's make sure x is greater than or equal to 0, because right here is where the graph in the back starts to have its problem. So we have its inverse equation, f inverse of x equals not plus or minus, but just the positive square root of x plus 9. And then the domain change makes that possible, and I've graphed both equations. Okay, and that's all I need. Okay, so that's it. Hopefully you'll do well on the final, and hopefully this makes sense. Okay, that's all I got.